Yeah, I think we can start. Dear delegates, I'm Christian Feichtinger, the Executive Director of the International Astronautical Federation, the IAF, and I'm very pleased to be your moderator of this symposium today. I would like to welcome you to attend this international symposium on the outlook and cooperation on near-Earth orbit human spaceflight. This symposium is co-organized by the IAF, the Chinese Society of Astronautics, and the China Academy of Launch Vehicle Technology. The symposium is aimed to share the achievements and future prospects of near-Earth orbit human spaceflight worldwide and promote international cooperation to contribute to the peaceful utilization of space. Let me start by expressing my sincere thanks to Mr. Wang Xiaoyun, Vice President and Secretary General of the Chinese Society of Astronautics, CSA, and Mr. Wang Xiaoyun, President of the China Academy of Launch Vehicle Technology, CALT, and also IAF Vice President for Societies and Museums for this outstanding initiative. Our symposium will be attended both in person in China, in Beijing. I'm very happy to welcome so many people present, and also remotely. The symposium is open online for our IAF community and also CSA's members. Now let me start by introducing to you our distinguished guest speakers of our symposium. They are Professor Pascal Ehrenfreund, President of the IAF and also President of the International Space University, ISU. She's connecting with us from Strasbourg in France. Mr. Liu Yaofeng, Deputy Director of the Integrated Planning Division of China Manned Space Agency. Mr. Wang Xiaoyun, Vice President of IAF and President of China Academy of Launch Vehicle Technology. Mr. Wang Xiaoyun, Vice President and Secretary General of the Chinese Society of Astronautics. Mr. Frank Devin, Head of the European Astronaut Center of the European Space Agency, ESA. He's connecting with us from Cologne in Germany. Mr. Sergey, Executive Director of Human Spaceflight Programs of the State Space Corporation of Roscosmos. He's connecting with us from Moscow in Russia. And finally, Mr. Gilles Leclear, Director General of Space Exploration of the Canadian Space Agency. A warm welcome again to about 30 delegates from the China Academy of Launch Vehicle Technology who are present now in the conference room in Beijing, and a warm welcome to all who are connected remotely from all over the world. On behalf of the organizers, I express my sincere gratitude for your participation. And now, to start off our symposium, the organizers will deliver their greeting remarks. First remark comes from Professor Pascal Ehrenfreund. Let me quickly introduce her to all of you. Professor Pascal Ehrenfreund obtained degrees in astronomy and biology at the University of Vienna. She was appointed as a fellow of the European Space Agency at the Leiden Observatory in the Netherlands. Upon completion of her doctoral studies, between 2001 and 2005, Pascal Ehrenfreund held a professorship in astrobiology at the University of Amsterdam and the University of Leiden, where she remains till today a visiting professor. In addition, between 2005 and 2008, she was a distinguished visiting scientist at the Jet Propulsion Laboratory in Pasadena, the USA. Since 3 decades, she contributed as principal investigator, co-investigator, and team leader to ESA and NASA astronomy and planetary missions, as well as experiments in low Earth orbit and on the International Space Station. In 2008, Pascal Ehrenfreund obtained a Master of Arts in Management and Leadership. Since then, she has been Professor of Space Policy and International Affairs at the Elliott School of International Affairs, George Washington University. She was the President of the Austrian Science Fund from 2013 to 2015. and the chair of the executive board of the German Aerospace Center, DLR, between 2015 and 2020. By the way, the asteroid 9826 Ehrenfreund 2114T3 bears also the name of Pascal Ehrenfreund. Pascal took up duty as IAF president at the IEC in 2019, and since September 2021, Professor Ehrenfreund also serves as the president of the International Space University. Now, please welcome Professor Pascal Ehrenfreund.
Yes, thank you very much, Christian, and welcome to the on-site audience in Beijing and online audience all over the world. The International Astronautical Federation is really pleased to continue our great cooperation with China, specifically with the Chinese Society of Astronautics and China Academy of Launch Vehicle Technology by co-organizing the symposium. I do a little bit apologize for the background noise. We have a very dramatic storm and there is a lot of wind in our buildings. So I'm really sorry for that. Yeah. But special thanks goes to Mr. Wang Xiaoyun, Secretary General and Vice President of the Chinese Society of Astronautics, and Mr. Wang Xiaoyun, President of the China Academy of Launch Vehicles Technology and IF Vice President. And the IF is really proud of our outstanding history of cooperation with China that has seen two record-breaking international astronautical congresses, namely in Beijing, the IAC 1996, and the IAC 2013, and two remarkable global conferences, namely the Global Lunar Conference in Beijing, the GLUC in 2010, and the Global Space Exploration Conference in 2017, all organized in close cooperation with the Chinese Society of Astronautics. So the Chinese Society of Astronautics is a key member of our federation and an IAF alliance partner. So the topic of this symposium is very, very timely, as a human spaceflight in low Earth orbit is high on the agenda of many stakeholder countries and private companies, and particular also in now in Europe, and I'm sure that Frank Devin will talk about that. So with presently two permanently habited space station in orbit, the ISS and the Chinese space station, the ongoing discussion about lifetime of the ISS and the announcement of private companies to launch commercial space stations in the future, such as Orbital Reef by Blue Origin, is an extremely attractive topic for this symposium. And I'm sure that our audience will profit from the presentations of our international high-level speakers. So I want to thank the organizers for giving me the opportunity to address you at this opening ceremony and wish the symposium the best of success. And I certainly hope that we will see each other again in person in the near future. Thank you very much.
Thank you very much, Pascal, for this inspiring introduction. The second remark comes from Mr. Wang Xiaoyun. Mr. Wang is the Vice President and Secretary General of the Chinese Society of Astronautics, CSA, and he is also the Secretary General of the IAF Select Subcommittee on Satellite Commercial Applications. Under his leadership, CSA has co-organized with the IAF a variety of activities, including the successful 2017 Global Space Exploration Conference, GLEX. As a research fellow, he has led and participated in numerous research programs, including the white paper of China's space activities in 2006, 2011, 2016, and 2021. Please welcome now Mr. Wang Xiaoyun.
尊敬的各位来宾、专家朋友们，大家下午好，晚上好。暮冬将远，群贤毕至。今天，中国宇航学会、国际宇航联合会、中国运载火箭技术研究院共同举办近地轨道载人航天发展展望与合作国际研讨会。在此，我谨代表中国宇航学会向研讨会的召开致以热烈的祝贺，对线上线下各位同仁的莅临表示衷心的感谢。载人航天是人类航天活动中最为复杂、难度最大、要求最严的系统工程。今年是中国载人航天工程立项实施30周年。经过30年出力奋进，中国载人航天取得了累累硕果。天河核心舱成功发射，标志着中国载人空间站建设进入全面实施阶段。6名航天员先后进驻中国空间站，实施出舱活动、舱外操作、在轨维护、科学实验等任务。中国载人航天工程取得了全面的发展，将进入为期10年以上的常态化运营、科学实验应用与发展阶段。与此同时，国际载人航天事业也将迎来一系列的成果。人类各种载人航天记录将被逐步刷新，迎来更为蓬勃发展的年代。越来越繁忙的太空需要人类更多的智慧和协作。中国宇航学会与国际宇航联合会长期保持友好合作关系，双方致力于通过学术活动推动航天国际交流与合作。在今天的研讨会上，期待各位专家多方位展示国内外载人航天技术成果，碰撞思想，汇聚力量，为国际载人航天储备技术、积累经验。大海之阔，非一流之归也。外层空间是全人类的共同财富，载人航天探索是人类共同的事业，离不开世界各国的通力合作。愿我们携手并进，为人类探索宇宙奥秘、维护外空活动的长期可持续性发展，打造人类命运共同体，贡献更多的智慧和更大的力量，向着星辰大海全力进发。最后，预祝研讨会取得圆满成功，谢谢大家。
Many thanks, Mr. Wang, for these very wise introductory remarks. The third remark is coming from Mr. Wang Xiaoyun. Mr. Wang is the Vice President of IDF and the President of the China Academy of Launch Vehicle Technology, CALT. He is also President of the Beijing Society of Astronautics and Board Chairman of Strategic Launch Vehicle Innovation Center of National Defense S&T Industry, and a corresponding member of the National Academy of Astronautics. He has made achievements in the fields of international exchange and cooperation, aerospace engineering, management, and academic research. Please welcome now Mr. Wang Xiaoyun.
尊敬的 Pascal Enhenfriend 主席 ，Christian Fechtinger 主任，各位嘉宾，亲爱的朋友们，大家好。为促进中国与不同国家、空间机构和国际组织开展合作，中国宇航学会与中国运载火箭技术研究院共同举办近地轨道载人航天发展展望 与合作国际研讨会。今天我很荣幸能够为大会致辞。首先，请允许我对来自欧空局、加拿大航天局、俄罗斯航天局以及中国载人航天工程办公室的各位专家表示衷心的感谢，对所有到场嘉宾以及线上观众表示热烈的欢迎。探索浩瀚宇宙和载人太空飞行是人类共同而又永恒的梦想。自1961年人类首次载人航天飞行以来，载人航天在带动人类科技进步和高科技产业的发展，利用空间环境资源，促进太空资源开发，以及加强国际交流合作方面发挥了越来越重要的作用。2019年以来，尽管受到新冠肺炎疫情带来的不利影响，但全球范围内近地轨道载人航天依然取得了突出成就。载人龙飞船、货运龙飞船等新型载人航天器成功实现重复使用。国际空间站俄罗斯舱段完成扩展，近地轨道载人航天能力得到加强。多国积极参与载人航天项目，并取得一定成果。此外，多家航天商业公司积极实施亚轨道、轨道、太空旅游项目，太空旅游业也进入了快速发展的新时期。在过去的1年里，中国空间站的建设进展迅速，伴随着天河献礼、天舟接力、神舰出征、神舟载梦，我们正在逐步实现天上宫阙的梦想。中国空间站关键技术验证阶段5次任务顺利完成，在轨组装建造全面开展，6名航天员先后进驻空间站等，这也标志着中国空间站已进入全面建设阶段。2022年，我们计划完成6次发射，实现空间站标准构型的建造，并开展空间技术、空间科学、空间生命等相关科学技术研究。下一步，我们还将邀请世界各国同仁共同推动空间站的建设和运营，共同分享载人航天的丰硕成果。女士们、先生们、朋友们，我们将秉持和平开放、互学互鉴的精神，与来自不同国家和地区的朋友们一道，共同推动空间站建设，促进世界载人航天技术的发展，打造国际合作交流新平台，为构建人类命运共同体贡献更多的智慧和力量。最后，再次对各位专家、各位来宾的莅临指导表示衷心的感谢，也对论坛主办单位、承办单位、全体工作人员的辛勤工作表示由衷的敬意。预祝本次会议圆满成功，谢谢大家。
Thank you very much, Mr. Wang, for your very interesting perspective also in your welcome remarks. And now it is my distinct pleasure to invite our keynote speakers to give their most interesting presentations. Our first speaker is Professor Pascale Ehrenfreund, and the title of her presentation is Future Perspectives of Human Spaceflight. Pascale, the floor is yours, please.
Yes, welcome everybody, and I hope you can see my slides. I would like to give a short presentation about the future perspectives. And I have to say that it is quite a fantastic time or age in order to engage in human spaceflight. And I have been myself working on many different experiments on the International Space Station, or CubeSats, and in low Earth orbit. And it is a fantastic time to continue those experiments. So first of all, I want to say that robotic and human space exploration are very closely linked. And I think it is, I want really to congratulate to only some of the really, really fantastic robotic exploration experiments of China, like Chang'e 5, and actually really bringing back 1.7 kilo of samples from the moon the first time after 44 years. So we hope there will be a very interesting results. And also we are really looking at this very, very great success of the Surrey rover on Mars, and that China actually landed a mission with an orbiter, a rover, and a lander at first attempt, and is exploring the Martian surface and has already published results. So that means also that there is really a fantastic time to do human exploration when we are going later on to the moon and to Mars. Human and the robotic exploration has to work in synergy. So we are seeing some kind of transition in the future of low Earth orbit activities. We have seen a lot of new models involving commercial space companies. We have seen the return of the US returning with a commercial crew to the space station. We have also celebrated recently the 20 years of continuous human habitation, and celebrated that there are more than 3,000 experiments which have been conducted on the International Space Station from 108 countries. And we also discussed this transition phase which is happening now, that we have a more commercial activities and companies which are looking for a market case and will actually build eventually at the end of the decade small commercial space stations. We are looking very much to China and this fast and amazing construction of the Chinese space station, and wish you good luck. And also India is moving forward with its human spaceflight Gangayaan project. So just to discuss very shortly how important these experiments in a low Earth orbit are. And when we look at the topics, biotechnology, technology development for many different subjects, there are a lot of educational activities. So where students can bring their experiments in a low Earth orbit, and that is not only important also for the individual activities, but also for their inspiration, the inspiration for the next generation to engage in space activities. A lot of this concerns human research, medicine, space medicine, which prepares, for human exploration to Moon and Mars. And physical sciences, also Earth observations. We have already instruments in low Earth orbit looking at back to Earth. So there are so many different experiments which can be done in low gravity in space stations, and I think there is a great future ahead, because many of those phenomena cannot be studied in Earth laboratories. We need a microgravity environment for that. So I was just also part of the Horizon missions of Alexander Gerst, and have at that time, being at DLR, really seen what is all happening in space and how important the experiments are. And there are some experiments on, for instance, space medicine, and looking at the immune system and looking at the holistic view of the body, and looking at psychological factors, looking at medical factors, how humans actually behave in extreme environments. And this is also very important for us. Other field is, which is very important, is artificial intelligence, and how do we introduce interesting experiments, and they are already used also on the International Space Station, and of course robotics in all forms. These are just a few examples. How do we actually test telerobotics, which we will need for future exploration ventures. So there are so many interesting experiments. I can only mention a few, but the low Earth environment, low Earth orbit environment is really, really also crucial to understand all the factors of astronaut health, and how they actually work in an extreme environment. What are the stress factors? How are muscles and the breaking down? How is the cardiovascular system? How does the immune system respond? And of course, how can we prevent in the future the radiation risk? So many experiments are done, and I personally have done many experiments concerning radiation on the International Space Station in order to understand the future of space exploration, to understand experiments which we also can do in deep space. So we congratulate you very much to this rapid construction. I hope all the numbers are right. You know that much better, but it is wonderful to see how fast China is proceeding and having regular missions, and will add more modules also for science with a telescope in the new years. We see that everything is going rapidly. I also saw that you celebrated the Chinese New Year on the China Space Station. So we wish you good luck with this endeavor. And there are many, I think, not yet so realistic ideas about how to make commercial space stations in probably 10 years from now. I'm a little bit involved in this project Orbital Reef, which should be really open for everybody in the world for research, for space tourism, and be open to all nationalities and to many kind of endeavors. Just previously funded, got a prior funding through the Space Act Agreement, and so are many other companies which are proposing, smaller space station. So it's an exciting time, and we hope also that international cooperation will help to bring this topic further. We can also not not mention, what is happening in space tourism. We have seen a lot of different missions being active last year from many different companies, be it Virgin Galactic, be it Blue Origin or SpaceX. And this is also a new era which will develop, and hopefully space will be accessible for all in the future. So I want to end with just mentioning a little bit about the International Astronautical Federation and what we are doing for space exploration and human spaceflight. The IAF was founded in 1951, and it is the world's leading space advocacy body with 433 members from 72 countries. And when we meet, we have really all stakeholders on board, be it industries, space agencies, research organizations, universities, you name it. And we are here really to advance space science, to foster the international cooperation all over the world, and also in order to inspire the young professionals and to form and educate the workforce of tomorrow. So we have a lot of activities, and Christian has mentioned it already. We had a fantastic global space exploration conference in Beijing in 2017. And just very recently, we organized the next global space exploration conference together with Roscosmos in St. Petersburg. And that was really a fantastic conference after, the pandemic, meeting the first time. And we also had, I think, 18 astronauts and cosmonauts with us, also explaining the next generation how important human spaceflight and activities in low Earth orbit are. So I just want to mention that we are also working on this topic in the International Space University. I'm now also the president. It's a space elite school founded in 1987, and it educates the future leaders of the world space community. We have many different international interdisciplinary educational programs, and we have a lot of Chinese participants. And right now we have over 5,200 alumni from 110 countries. And we have also a Chinese member on our faculty, Professor Gongling Sun from CASC. And this summer, when we are meeting for our summer study program in Portugal, we will have a team project where all students are working together from many different disciplines. And the topic will be international cooperation on the use of the Chinese space station. So we are very much looking forward. There will be a report, and that is available to everybody. So let me just wish you a lot of success and really state again that there is a new age for low Earth orbit and human spaceflight. It is exciting, and China is a big player in that. And I want to wish you really good luck for your symposium.
Thank you very much, Pascal, for this really inspiring presentation summarizing the achievements of the Chinese space program, the International Space Station, how all these experiments and activities contribute to the future of space exploration beyond low Earth orbit. And thanks a lot also for introducing the IAF and the ISU and flagging the importance of fostering the next generation of space leaders. Thank you very much. It is now the opportunity to ask a few questions. If there are any questions from the audience, please come up. Professor Ehrenfreund is still available to answer them. Yeah, I see somebody running already with a microphone, so maybe we have a question there.
尊敬的艾亨劳德主席您好，您刚才介绍了这个IIF， 就是我们的国际宇航联合会，在这个近70年来，在国际交流与合作领域都取得了极大的成就，也促进了很多这国际合作的开展。我想问您一下，我们 IIF 如何通过自身的优势来进一步推动国际空间站向全球更多国家的这样一种交流与合作的形式？谢谢您。
Thank you very much for this very valuable question. I think that is actually what we are doing at all our large conferences. Let me make one step back. The IAF has many different committees, technical and administrative committees. You can see that on our website. And we have also many committees which are dedicated to human spaceflight. Or habitation and many of those subjects. And those committees are completely international. This means everybody from the whole world is working together in these committees. They are producing briefs and short papers, which you can find on our website. They are open accessible. But additionally to that, we are, for instance, always organizing an international panel of space agencies at every conference where all nations, including China, are discussing about their future endeavors. And our International Astronautical Congress, which is held every year in a different country. Was already twice in China, offers a lot of panels and special sessions and where people can network and connect. And I would also like to give the word to Christian Feichtinger, who is the executive director, because he has also a total oversight over everything. If he still wants to add something.
Thanks a lot, Pascal. I mean, you said it all. I just wanted to kind of add maybe to the specific question on how emerging countries, how we, the IEF, can help emerging countries to enter the space community and specifically also maybe have access to the ISS. I would just like to mention that we are, for the second time, going to organize and host a global space conference for space for emerging countries, the so-called GLEC 2022. This conference took place for the first time in 2000, I think it was 19, in Morocco, Marrakesh, and now we will meet again in Quito, in Ecuador, in May, 14th of May. It will start this year. And the topic there will be, of course, the topics will be manifold, but one of the topics certainly will also be how emerging countries can profit from human spaceflight and can participate in the human spaceflight programs. So I would like to invite everybody interested to join us in Quito in May this year. Is there any other question from the audience?
谢谢您，谢谢您，我也会持续关注我们 IIF 举办的后续的各种会议。谢谢您，谢谢二位。
Thank you very much. Appreciate. Okay, I think then we can move on. And our second speaker is now Mr. Lü Yaofeng. Mr. Lü is Deputy Director of Integrated Planning Division of China Manned Space Agency, CMSA. Mr. Lü has worked with the China Manned Space Agency since 2011. At present, he is the Deputy Director of Integrated Planning Division of CMSA, and he is in charge of international cooperation, missions implementation and communication, and public promotion. Before joining CMSA, he worked with the Astronaut Center of China. Mr. Lü has gotten his master's degree in international relations from the Beijing University. And the topic of Mr. Lü's presentation today is Progress of China Space Station. Mr. Lü, please, the floor is yours now.
Okay, thank you. 尊敬的帕斯卡尔主席、王晓军院长、各位专家、各位代表。我今天非常高兴呢，能够代表中国载人航天工程办公室来参加今天的会议。那么我下面主要分这个4个方面给大家来分享一下中国空间站的一些最新的进展。大家都知道，但是每次都得从这儿开始讲啊。我们工程呢是92年立项的，那么当时明确了这个3步走的一个发展的战略。那么第1步是解决一个载人的天地往返的问题。那么第2步呢，主要是这个突破这个交会对接技术，以及建造空间站的一些关键的一些技术。那么第3步呢，是建造中国自己的空间站，解决有较大规模、长期有人照料的这个空间应用问题。那么从1992年到2005年，实际上我们通过实施4次无人和2次载人的这个任务，实现了这个载人的天地往返。工程第1步任务也圆满的完成。那么从2005年到2017年，我们先后呢实施了航天员的这个出舱活动、空间交会对接开展了这种空间的物资补给、推进剂的补加、航天员的这个中长期的驻留，以及一系列的这个空间科学实验与技术试验。那么先后发射了2次这个我们第一个叫天宫1号目标飞行器，第2个叫天宫2号空间实验室。那么这相关的全部系列的任务呢， 全部得到了圆满的一个验证，整个工程的第2步的这个任务也圆满完成。那么从2020年5月开始，实际上我们讲这个空间站的建造是基本上从长征5号 B 这个首飞任务为开端的，实际上是拉开了中国载人航天工程第3步的一个任务的序幕。那么按照这个任务的规划呢，我们从2021年到2022年一共要实施11次的一个高密度的一个任务，包括3个空间站舱段的这个发射，以及这个4次货运飞船以及4次载人飞船的发射。那么在今年的年底建成中国的空间站。中国空间站的这个基本构型是由核心舱和2个实验舱组成，整体呢是一个 T 字形的结构。那么完整的构型呢大概在90吨级，可以支持这个货运飞船、载人飞船以及其他来访飞行器的这个对接和停靠。那么整个的设计寿命是在10年，不少于10年。额定乘组3人，短期轮换呢可以到6人。那么航天员可以实现在轨的一个长期的驻留，那么并且开展较大规模的一个空间科学实验和应用试验。此外呢，还要单独发射一个这个巡天光学望远镜，与空间站共轨保持飞行，同时呢，也支持这个空间天文的这个领域的研究。那么从去年的4月29号，我们使用长征5号 B 遥2火箭成功发射了空间站的核心舱。在它入轨之后呢，按计划完成了交会对接、航天员驻留、机械臂、平台功能测试以及一系列的这个相关的这个功能性能的检查。那么各项功能都很正常，运行状态也良好，那么具备开展这个后续任务的一个条件。核心舱呢是中国空间站第1个发射入轨的一个舱段，主要用于统一控制和管理中国空间站，具备长期自主飞行的能力。可以支持航天员长期驻留，开展航天医学、空间科学实验和技术试验。配备了这个机械臂和这个再生式的环控声保系统，同时呢，搭载了无容器这个材料的一个科学实验柜，以及这个医学样本分析和高微重力科学的一个实验柜，还有一个人系统的一个研究实验柜。那么这次任务的一个圆满成功呢，实际上标志着空间站在轨组装建造全面的一个展开，那么为后续的这个我们整个组装建造的这个任务吧，奠定了一个坚实的一个基础。5月29号，这个发射了这个天舟2号货运飞船，那么采用自主快速交互对接的这个模式，精准对追于这个天河核心舱的这个后向的一个端口，那个整个过程呢大概历时8个小时。那么完成这个交会对接以后呢，转入了一个组合体的飞行，按照计划开展了这个推进剂的补加以及这个空间应用设备的这个测试的这个工作。简单介绍一下天舟2号的这个货运飞船，那么它共运送了大概6.9吨的这个货物，货载比呢超过了50%，包括航天员的生活物资。以及这个我们中国自主研制的这个新一代的飞天的舱外航天服，还有一些空间站的一些平台设备，应用载荷、推进剂，那么这次任务的这个自动快速交会对接，实质上也是天舟货运飞船与长征7号火箭组成的这个货运系统的首次的一个应用性的一个飞行。就在上个月，我们利用这个空间站的这个机械臂。使用这个天舟2号，做了一个这个货运飞船的一个转位的实验，这也是我们国家首次利用这个空间的机械臂操作大型的在轨飞行器进行一个转位，那么也是验证了这个利用大臂来这个操作空间站舱段转位的这个可靠性和这个有效性，同时呢，验证了这个舱段转位技术和机械臂大负载的这种操控技术，为后续的这个空间站在轨组装积累经验。那么在6月17号，神舟12号任务呢， 我们顺利的将聂海胜、刘伯明、汤洪波3名航天员送入了太空，这也是空间站阶段的首次的一个载人飞行任务。6个半小时以后，这个飞船以这个自主快速载油对接的一个模式，与核心舱前向端口进行了一个成功的对接。那么与之前发射的这个天舟2号货运飞船一起构成了一个组合体。那么中国空间站呢，实际上迎来了第一批的这个太空的这个访客。那么根据这个任务安排呢，他们在轨一共停留了3个月。期间呢，开展了这个组合体的这个日常管理、出舱活动、舱外的操作，以及多项的这个科学实验和技术试验，以及航天员自身的这个健康管理。那么期间呢，也执行了2次的这个出舱活动，那么进一步检验了我们新一代舱外航天服的这个功能和性能，以及航天员与机械臂的这个协同的一个工作能力，还有就是出舱活动相关设备、支持设备的这个可靠性和安全性。那么9月17号呢，3名航天员安全的返回了地球。那么空间站阶段的首次载人飞行任务取得了圆满的一个成功。9月20号，我们发射了第2艘这个货运飞船，同样也是采用一个自主快速交会对接的模式，对接的这个天河核心舱的一个后向的一个端口。那么在它发射之前呢，天舟2号进行了一个转位、一个绕飞，对接到了这个核心舱的一个前向的一个端口。值得纪念的是呢，这是工程的第20次发射任务，整个载人航天工程可以说是20载20节。然后在10月16号的时候发射了这个神舟13号载人飞船，使用的是我们金牌的这个长征2号FF 遥13火箭。那么整个这个同样也是采用这种自主快速交会对接的模式，与此前的这个天舟2号、3号还有核心舱一起构成了一个组合体。那么11月8号和12月27号2个这个乘组呢完成了2次的这个出舱活动，也是完成了所有的既定任务。这个王亚平呢也成为我们中国第一个进入空间站的女性航天员，同时也是第一个执行出舱任务的女航天员。这个地方值得一提的是，我们在这个12月9号的时候，我们组织实施了这个天宫课堂的这个第1课的一个正式开讲。实际上在8年之后吧，中国航天员再次在太空给孩子们带来了一堂精彩的一个科学课。这个太空教师，我们3个航天员翟志刚、王亚平、叶光富，这个为青少年们带来一场非常精彩的这个太空的科普课。这也是中国空间站首次进行这个太空授课的一个活动。那么我们也查了相关方面的数据，在12月9号到12月10号不到24小时的时间内，有超过20亿人次，通过直播或者是网络，或者是这个重播观看了我们这次这个太空授课的一个活动。那么整个神舟13号任务呢，实际上也是创造了中国载人航天史上很多个首次，比如说首次这个飞船采用一个自主快速交会对接的一个模式，从径向停靠空间站，包括我们首次运控这个4个飞行器形成的一个组合体，包括首次航天员要在天上驻留6个月，同时刚才我也讲到了，就是中国首位进驻中国空间站的女航天员，也成为了首位实施出舱活动的女航天员。那么从目前看呢，空间站整个的这个平台各项功能非常正常，相关的实验和技术实验也进展顺利，航天员的身体状态非常良好，计划4月返回。那么整个今年的规划呢是要实施6次的发射任务，还有2次的返回任务。发射包括梦天、问天实验舱以及两艘这个载人飞船和2艘货运飞船，于年底呢完成这个空间站的一个建造。那么之后呢，进入这个应用与发展阶段，可以支持开展大量的这种科学研究和实验。与此同时呢，中国空间站这个 国际合作的大门也向全世界敞开啊。那么对于有志于开展太空科学研究的科学家来说，中国空间站将为他们提供一个非常完美的一个实验平台。不对，按错。OK。那么整个外层空间呢，实际上是人类的一个共同的资源。那么中国载人航天呢，始终将和平利用外空、合作共赢作为一个发展的理念，以开放的这个姿态呢，开展国际间的交流与合作。从这个工程立项实施以来吧，我们先后与世界上很多个航天机构啊，包括联合国的外空司啊，包括欧空局。俄罗斯、德国、法国、巴基斯坦、意大利等国家的这些航天机构，包括我们的 IAF，我记得在交会对接任务的时候，我们就搭载了一面这个 IAF 的会旗，并且在2012年还是13年，在德国把这个会旗还向这个当时的主席，然后也进行了一个移交。实际上我们在航天器的这个平台技术、空间科学实验以及航天医学、航天员选拔方面呢，开展了大量的这种合作项目。那么以下呢，我简要介绍一下这个跟国际组织这个合作的一些情况。第一个呢是跟这个联合国外空司，我们从2016年开始，与外空司合作，面向这个所有的成员国征集这个搭载到中国空间站的合作实验项目。经初选和定选2个阶段呢，最终这个在19年的6月。双方共同这个发布这个首批中国空间站应用项目的一个定选结果，一共是有17个国家，9个项目成功的这个就是被选中作为第一批到中国空间站开展实验的这个项目。那么这些入选的这个项目的这个领域呢，这个包括了这个空间天文、空间生命科学与生物技术。微重力流体、燃烧科学等多个领域，当然好像我记得这个项目里面也有一个是国际空间大学的，因为我本人也在国际空间大学也学习过，这些可以通过这个表可以看到这个参与的一个广泛程度，就是这个各个科学团队来自很多个国家。那么下面我介绍一下跟欧洲空间局的一些合作。那么2014年呢，双方实际上是共同修订了这个政府间的一个合作协定，那么签署了一个机构间的一个合作框架协定。那么实际上从2015年之后呢，中欧载人航天合作建立了一个固定的一个长期的一个机制，那么下边设了若干的这种工作组，实际上从围绕这个航天员的训练。航天员的食品包括中国空间站载荷的一些接口标准，空间碎片的撞击实验，还有空间科学实验等领域吧，其实开展了很多合作。中欧载人航天的那个一共有10个合作项目，在双方的机构得到了立项，共有来自23个国家、95个机构的158个团队。我刚才看到这张图的时候，我刚才我说错了，这个应该是对欧空局合作的一个情况。那么涉及到了这个空间生命科学和生物技术，微重力、流体与燃烧，空间材料科学等领域。实际上目前呢，双方的团队正在按照计划开展这个合作的研究。实际上整个这个合作呢，实际上是2个航天机构拿出部分自己的这个空间的资源，来支持双方的这个科学家利用各自的这个飞行机会包括国际空间站、中国空间站。还有欧洲的一些失重飞机的一些飞行机会，然后来开展一些合作。那么在前期良好的这个合作基础上吧，其实我们跟各个合作伙伴在不同的领域一直在务实的推进这种项目的进展。那么今后呢，我们觉得在空间科学与应用中外航天员的联合飞行还有技术成果的转化，我们将继续加大与这种国际航天组织与航天机构合作的一个深度和广度。这个使世界上更多致力于和平利用外空的国家和地区能够参与到这个载人航天事业中来，将中国空间站呢打造成为面向国际社会开放的一个科技合作交流平台。 所以我也非常欢迎各位国际的朋友能够积极的组织相关的这个团队加入到我们中国空间站这个国家级的太空实验室中共同开展这种科学的研究，来造福我们全人类。那么最后呢，请允许我用一个我们中国航天员的老朋友也是欧空局的这个航天员托马斯，也是 Frank 的他的下属还有我们中国的女航天员王亚平在太空演奏这个中西方乐器的一个照片，作为这个结语吧。期待未来我们能够收获更多的这种合作。那么谢谢大家的关注。
Thank you very much, Mr. Liu, for this really exciting presentation outlining the stunning speed of development of the Chinese space station over the last years, the perspective of its further development, and most importantly also underlining the openness of China for international cooperation that is already in full swing. So that's really exciting. It is now again the opportunity to ask some questions, and I have already one question from the international audience coming in. And the question was about your plans for 2022, for this year, in terms of EVAs on the Chinese space station.
2022 or 2021? Sorry.
The question was about extravehicular activities this year on board the space station.
Okay.
What are the plans?
This year, so in last year we carried out 4 times of EVA, and this year according to the plan, but I don't remember the exactly number of the times of the EVA, but actually we need to do some modification on the outside payload, or including some equipments of the space station. So I think normally we would say one crew would carry out 1 or 2 times of EVA during the 6 months mission.
Okay, thank you very much. Maybe we have another question from the audience in Beijing.
They know well our plan.
They know it too well. But then let me ask you one question, if you allow me.
Okay.
How does China see the stage of developing and operating the Chinese space station as a stepping stone for human exploration beyond low Earth orbit?
Oh, that's a quite good question. I think there are many works we can do based on this station, especially for demonstration some new technology for the deep space. So we can verify some new technology for the future's manned spaceship, including the new launch vehicles, while this space base, because it's a perfect platform for all this technology testing. So currently we are doing some pre-studies on the deep space program, but now we don't have the specific program. But I believe we can make full use of this space station for the future lunar or Mars missions.
Well, thank you very much, Mr. Liu. This is really exciting information which we received from you. And I would just like to mention that in October this year, we will have our annual International Astronautical Congress in Paris. And I would really look forward to welcoming you and your Chinese colleagues to give an update on the status of the Chinese space station development and operations to our global audience that will be present in Paris. Everybody would really enjoy that.
Okay, thank you very much for the invitation. Okay, thank you.
Thank you.
谢谢。
Thank you very much. We are now moving on to our next speaker, who is Mr. Frank Devin. He is the head of the European Astronaut Center of the European Space Agency, ESA. Let me please shortly introduce Frank to you. It would take quite some time to introduce all his achievements over his career. Let me just focus on a few. Holding a master's degree in telecommunications and civil engineering from the Royal Military Academy in Brussels, Belgium, Frank graduated from the Empire Test Pilots School in Boscombe down in the United Kingdom. After completing his flight pilot training with the Belgian Air Force in 1986, Frank became a test pilot, and he logged more than 2,300 hours flying time on several high-performance aircraft, including the Mirage, the F-16, Jaguar, and Tornado. In January 2000, Frank joined ESA's astronaut corps based at the European Astronaut Center in Cologne in Germany. And in autumn 2002, Frank flew his first mission, the Odyssea mission, a support flight to the International Space Station, where he served as a flight engineer on the updated Soyuz TMR spacecraft during launch and on the Soyuz TM for re-entry. And during his 9-day mission on board the space station, Frank ran 23 experiments in life and physical sciences and also education. Then in 2009, Frank was sent on the Oasis mission, a long-duration flight to the International Space Station. As part of Expedition 21, Frank became the first European commander of the orbital outpost, and he was also Soyuz TMA-15 and Expedition 20 flight engineer. One of Frank's key tasks during this mission was to operate the station's robotic arm to dock Japan's first HTV cargo vehicle. He was also the main operator of the Japanese robotic arm used to transfer experiments to Japan's external payload facility on the country's Kibo laboratory. Frank became head of the ESA's Astronaut Center in Cologne, Germany on the 1st August 2012. And since 2017, he has been in charge of International Space Station operations at ESA. And in 2020, he became ESA's ISS program manager. And now it is my pleasure to hand over to Frank for his presentation titled The European Exploration Program Today and Tomorrow Towards Terra Nova, Period 3. Frank, please, the floor is yours.
Thank you very much, Christian, for this nice introduction, and I hope it was not too long for the audience. Let me also start to say hello to Mrs. Pascal Ehrenfreund, that I also knew from here in Cologne, and where we had very interesting work together, but also to Mr. Lu Yaofeng. It was a pleasure to see him again and to listen to him again after a long time. We met many times before the pandemic, working together between CMSA and the European Space Agency. Some of the work that we did together was mentioned by Mr. Yaofeng, and it was really a pleasure for me to see him and to congratulate him actually today as well on all the progress that CMSA has made today with the Chinese space station. I will talk a little bit about our European exploration program, what in Europe we are trying to do and what we will propose to our ministerial conference in the next ministerial that will happen in November this year. So every 3 years in Europe, the ministers meet and decide on the future of our space programs in general, but also on our exploration program. And so this will be an important milestone again for ESA and for our program. So here is a little bit the overview of how our program looks like today. Mrs. Ehrenfreund already mentioned that humans and robots need to go hand in hand. And this is exactly what we are doing in Europe. We have one exploration program that encompasses all the human and robotic exploration. And so, of course, in low Earth orbit, we have the International Space Station, which is a key component for human spaceflight today. But we are also progressing in our quest to send humans to the moon, initially to the Gateway in cooperation with our American, Japanese, and Canadian partners. And ESA is a big part of the Gateway program. We are doing studies if we can go to the surface of the moon, and we will come to that later. And of course, we are also exploring Mars. We have an orbiter in Mars today, the Trace Gas Orbiter. That was the first element of ExoMars. But of course, we hope to launch later this year in September our ExoMars mission with the Rosalind Franklin rover. And we hope that we then can join our Chinese and our US colleagues also exploring the surface of Mars with robotic means and with a rover. So why do we do exploration in Europe? Because of course we work with public funding. We need to make sure that we give benefits back to society. And we have identified, we ESA, but our member states and our ministers have agreed that we do this for four main reasons. First of all, knowledge, science, and I think Mrs. Ehrenfreund and Mr. Yao Feng have indicated that very much. There's all the science that we can do in low Earth orbit, but also beyond. But it's not only science, it's also economy. Of course, we have industry, we have innovation, we have new products that we can make. So it's also supporting jobs, in high-level jobs in our economy. It's important. Inspiration with the astronauts, it was mentioned several times. I think certainly these days we need also to give a future perspective. We need to inspire the new generation, and astronauts and human spaceflight is certainly helping to that. Look only at the number of people that tuned in to the first lecture from space in China. It's quite impressive. So this is certainly also in Europe the case. And global challenges, space in general, but also human spaceflight can help us in combating global challenges for which we will need a lot of cooperation around the globe. And of course, human spaceflight is one of the catalysts of this cooperation. It's an area where I think we can all work together and we can all achieve common goals. So these are the four reasons why Europe is investing into space exploration. And we have basically split up our program in a number of cornerstones. One is, of course, the low Earth orbit. The second one is the Gateway, which is around Moon, then the lunar surface, and then Mars. It's a little bit what you saw on the first picture. So the cornerstone one, of course, remains today a fundamental element of our program. And that's, of course, the ISS, the International Space Station, is entering a golden age of scientific and commercial utilization. Since we have the launches of SpaceX vehicle in the US, we have now augmented the crew from 6 people to 7 people on board of the International Space Station. And this means that we have almost doubled the amount of crew time that is available for science. And also we see this in Europe. We have big investments from our member states through ESA, but also a lot of the member states are flying national payloads. Mrs. Ehrenfreund alluded to it as well during the mission of Alexander Gerst, for example, but also now during the mission of Thomas Pesquet that is just back, Matthias Maurer, Samantha Cristoforetti. We have a lot of payloads as well that is coming from our national research institutes that we can fly. Of course, we have to realize that our Columbus module is up there already for more than 10 years. It was designed 20 years ago, so we need to do a midlife update. The scientific experiments, the demands that we have from our scientific community today are much bigger than the demands that we had 20 years ago. So that's why we are upgrading our Columbus module with a high-speed data link. that we are also utilizing it in a more commercial way. The Bartolomeo is a commercially operated external payload platform that we have installed on board of the Columbus. We are totally modernizing the IT infrastructure of our module. You can understand that IT has evolved a little bit over the last 20, 30 years. I think everybody understands this clearly. And so we will make a very modern based IP-based IT infrastructure on board of our module so that scientists can have a more direct access to their payloads, to their data, and can turn around the science much faster than they did in the previous years. And we have just launched the Nauka science module on the Russian side, for which I want to congratulate our Russian partners. And we have, of course, our European robotic arm that is part of that Nauka module. So we are also looking forward to start using the European robotic arm. So we talked a little bit about the benefits as well that this brings, that the ISS brings. Well, here you see some of the benefits that we have, that the number of partnerships that we are having. Mr. Yao Feng mentioned it as well. Also with China, we have a very good cooperation on science, on the ISS, and in the future on the CSS. More than 3,000 research investigation in 108 countries that were led through Europe. But it's not only science, as said, it's also economy. It's profitable. Every euro that our member states invest in the International Space Station brings an impact of 3 euros back on the economy on Earth. So that's a very good return on investment. Inspiration, we talked about it. More than 22,000 astronauts have applied for the new astronaut selection in Europe. So you see that there is a big interest in being part of this exploration about this very inspirational program. We have a competitive industry. And so that's very important because, as Mrs. Ehrenfreund also noticed, we go into a new era of commercial utilization, commercial space stations. How can Europe and European industry be part of this new commercial endeavor that will undoubtedly happen? And so we have a number of smaller initiatives so far with the IceCube services, the Bioreactor Express, the Bartolomeo external platform, as I said, but that are very successful. But we are also now looking, and we have just issued a request for information to European industry, how they can be part of this new commercial space stations that are being developed all around the world, be it Blue Reef, be it Axiom, be it other initiatives. And then, as we said, education is a very big part of our program as well. Mr. Thomas Pesquet, with his last flight, has more than 2.6 million followers on Facebook. So I think this is an extremely good success to see how we can reach out to young people. So talking about the astronauts, how we reach out, because they are kind of the top of the iceberg that we use to reach out to all these new young people, that we use to inspire the general public. For the first time, we have 3 missions back-to-back to the International Space Station. Thomas Pesquet flew from April 21 to November 22. He was then replaced by Matthias Maurer, that is now on the space station, and he even sent a message of congratulations to his Chinese colleagues on the Chinese space station during his mission after the successful launch. And Samantha, that will fly in spring this year, actually flying to ISS on the 15th of April. It's very good that we have these 3 people that are actually also the 3 people, the 3 astronauts that started learning Chinese and that have worked already with our colleagues from the Chinese Astronaut Center. They have trained together with them. They have done survival training with them. And so they are very well known by our Chinese colleagues. And now, of course, they will come back for their 2nd or 1st space mission and will be even able to contribute more to the international cooperation. But we don't only fly to low Earth orbit. As mentioned by Christian, we also want to use the ISS to go further. And further for us, the first step is the gateway. We have signed an MOU with NASA in the framework of the Artemis program, in which we will have 3 flights of European astronauts to the gateway, so flying towards the moon, not yet on the moon, and that is the goal for our period 3. We will come back to that. We would also like to set up a cooperation with our colleagues from the US to have really also astronauts, European astronauts, walking on the moon. So science, we talked a little bit about it as well. The most science we do today is on board of the International Space Station in low Earth orbit, but it's not limited to International Space Station. We do a lot as well on parabolic flights. We do a lot on ground-based facilities. We do a lot on sounding rockets. And this for us is one, I would say, global scientific endeavor. We are not really separating our science program if it's International Space Station or sounding rockets. It's part of one comprehensive strategy where we want to use all these different platforms with all the capabilities and limitations that they have in the best possible way. And you see some of the highlights here. The one that you see on the right is certainly a big one. There was an article on Nature on the bolts, the blue bolts that are actually sprites coming out of thunderstorms, but not going down like lightnings, but going up to the atmosphere. And there is very little known about these. And there's our ASIM instrument is really generating a lot of data on this unknown phenomenon in our atmosphere. Moving on to our second cornerstone, which is the gateway, flying astronauts to the vicinity of the moon. There, of course, we are participating in 2 ways. In the first way, we are building a lot of modules for the gateway. The ESA is the second biggest partner in the gateway program. We are providing the international habitation module where the astronauts will stay, but we also providing a refueling and observation module and a communications capability for the gateway. So this is a very comprehensive package. And we are also providing the first payloads to the gateway, especially linked to radiation and the space environment, because of course, once we move out of our low Earth orbit and further into space, one of the big unknowns is the radiation environment and the impact of it for long duration space flight to the human body. And as already mentioned, we will have 3 astronauts that will fly to the gateway before 2030. And here you see some artist impressions, but not only artist impressions, also real hardware of the Artemis 1, the Orion capsule being integrated in the integration hall at KSC. The rollout is planned for the 8th of March, and we are looking for a launch within the first half of this year of the first Orion module. And ESA is actually delivering the service modules of this Orion capsule. So basically the propulsion elements, the power elements, all the tanks, everything that you need to have in a service element for a spacecraft is developed here in Europe and is delivered to NASA. We are under contract to fly or to build the first 6 service modules for the first 6 Artemis missions. And we are under preparation to also sign the contracts for the next 3 Artemis missions. So that will mean that the first 9 Artemis missions that our colleagues of NASA will do, ESA is on the critical path, and ESA is participating in building the service modules for those flights. And then the surface of the moon. Of course, we are not there yet. Why do we want to go to the surface of the moon? Of course, we want to understand how to live and work there as well on a longer term basis. I think also our colleagues from China have a program together with our Russian colleagues to establish a lunar moon base. The idea is not to plant a flag, of course, but to do sustainable exploration, sustainable scientific research on the lunar surface? Can we try to see, can we do technology development, how we can use resources on the moon? Can we use them locally? Can we use them as a base to have further trips to Mars? All this needs to be discovered, needs to be researched. And of course, that will be a long-term research. It will not be very quick, very short, but we think we need to start. And we also see there opportunities for our European industry. And of course, all this in the prospect of learning lessons and build capabilities to enable a further exploration to Mars. And that brings us, this is, one more view graph on the moon. Of course, if we want to have European boots on the moon, if we want to have European astronauts on the moon, we will have to participate in the Artemis program in a substantial way. And the way we see this today is that we will bring a large European lander, it's called EL3, that we will bring to the surface of the moon, that will be able to deliver 1.5 tons of cargo to the moon. The cargo can be cargo in support of human missions. It can be electrical power platforms. It can be rovers. It can be science payloads. This all still needs to be defined, but we first want to establish the capability in order to have a cargo transport capability that is in support of human missions in the human environment. And of course, this will allow us to have also European astronauts on the surface of the moon. And this brings us to Mars. As said, in Mars, we have, of course, now our trace gas orbiter of ExoMars, and then we have the ExoMars rover that we need to fly this year, and that hopefully will land successfully. But we are also working with our colleagues of NASA to have a first Mars sample return mission. This mission was defined with an Earth return orbiter that will be delivered by ESA. So it will be the first spacecraft that will fly to Mars, but from Mars then come back to Earth and deliver the payload back to Earth. We also have a sample fetch rover and a sample transfer arm that will allow the samples from the Martian surface to be transported to the ascender that will then rendezvous and link with the Earth return orbiter. There is some evolution in the architecture as usual. In the beginning, we have a lot of plans, and then when we go more into the detail, we see there are some limitations. And for the moment, we are studying together with NASA and JPL how we will further develop these plans to make the sample return possible in the early 30s. So this is a little bit where we are today. We have ExoMars, we have Mars sample return, we have the Orion, we have the gateway elements, and we are the ISS partner. This is what we will also work on between 2020 and 2030. This is what we have to implement. These programs are decided, but what do we want to do more in the 2030s to 2040s? Can there be new European-led partnership to the moon, to Mars for other robotic missions? Can we evolve further in cooperation on human operations on the moon and eventually later on Mars? Because absolutely we want to be part of the human exploration of Mars as well. What will bring the post-ISS commercial environment? How can our industry be a player in that? Can we do transfer in the lunar environment? Can this be interesting for ESA? But also, can we develop independent human access to space? There was a space summit just yesterday where the ministers have decided that ESA should investigate and develop initial plans to see if Europe should also have its independent capability to fly astronauts to space. And of course, we are very excited about that. The European astronauts have written a manifesto in support of the Space Summit that is available, that has been tweeted by our Director General. So maybe it's interesting also for the people of the conference to have a look this European Astronaut Manifesto. And this is my last view graph, just a little bit where we are before in period 2. So what we are executing, what the ministers had decided 3 years ago. You saw the same elements, but here you see a little bit more all the elements that we also want to decide in this year and want to start developing, amongst others, the large European lander, European astronauts boot on the moon, and further cooperation on Mars. Thank you very much for your attention.
Thanks a lot, Frank, for this most exciting status, but more even outlook into ESA's plans for human space exploration. I'm sure there will be several questions now to you, if you would still be available. Do we have a question from the audience in Beijing?
Very much, Mr. Frank de Waal. Thank you for your wonderful presentation. I have a question about the European. Okay, sorry. I have a question about the European launch vehicles. Could you share about some information about the next Ariane launch vehicles, European? And do you have any plan of the manned launch vehicle in Europe? Thank you very much.
So yes, in terms of the launch vehicles, you know that we are now working on our Ariane 6, which is the next European launch vehicle that we are preparing to do its maiden flight, and it will be the workhorse of the European launcher capabilities in the short term. You have seen that we are planning to use this launch vehicle for our large European lander on the moon, the Ariane 6-4, because there are 2 versions of the Ariane 6, one with 2 boosters and one with 4 boosters. So the heavy version we would like to use for our large European lander. And of course, if we want to study, if we want to have our own human access to space, of course, we also need to see how we will do this, which launcher we will use. This today is not decided. We are at the very first stage to thinking, should it be an Ariane 6? Should we do something different, like also our colleagues in NASA has done with SpaceX or with other companies? Shall we look to new endeavors, a new industrial setup to make also the human capability, a human-rated launcher, and human capsule available in Europe for European astronauts to fly. This is something that is in the very, very early stages. We have just yesterday gotten the direction from our member states to look, should Europe or not go into that direction? It's first of all a political question that we need to answer. We hope to have that answer by the end of the year. And then the second question is, of course, if our political decision makers decide that Europe should also develop its own capability, then of course the second question will be, how shall we do that? And that question is for the moment not yet studied or answered.
Thank you very much, Frank.
Thank
you. We've still received also from our international audience some questions, and one of the question or several questions go in the same direction, asking when ESA astronauts would be planned to fly potentially on the Chinese space station. Of course, this question maybe also goes to our Chinese colleagues, but maybe you can give us the ESA plans and perspectives on this.
Well, we can also relate to Mr. Yao Feng. We have discussed this very often in the past. So we are certainly interested to continue to work with our Chinese colleagues from CMSA and have some of our astronauts fly to the Chinese space station. The question of when is has a number of aspects, I think. First of all, when would the Chinese space station or our Chinese colleagues be ready to accept international astronauts to their space station? Because I understand that today they are still in the build-up phase, so it's not the most easy way to do that. The second thing as well, we need, of course, to develop what is then the nature of the cooperation. I'm quite sure that if we do this, it needs to be in the mutual benefit both of ESA and of China and the Chinese Manned Space Agency. And so we still also need to make progress to see what are the mutual benefits and what can be the elements of such a cooperation. But I'm certainly looking forward to continue to discuss this with our colleagues from China. We have been delayed a little bit in the discussions because of the COVID situation. It does not make it easy in these times where we are almost not allowed to travel to continue the cooperation, but I'm sure that we will pick this up again.
Thanks, Frank. Is there anything maybe Mr. Liu wants to add from Beijing on this question?
No, I just want to ask Frank a question. Sorry. Okay. By the way, his answer is also mine.
That's already a good basis for future cooperation.
So my question to Frank is, so you just mentioned the ESA will got involved in the lunar human flight mission, and also mentioned ESA is carrying out the new batch of astronaut selection. So my question is, will you send currently active astronaut to the moon, or you will send new guys to the moon?
The plan that we have today, but okay, plans can always change, as you know. The plan that we have today is that the astronauts that we will select now will first fly to the International Space Station. The aim is that they will be selected by October, November this year. They will start their basic training, and we hope that they can do their first flights to the ISS starting 2025. The flights that we have to the gateway are between 26 and 2030. And our current thinking is that those flights will be done by experienced astronauts that have already had a flight in low Earth orbit. Now, as I said, these are the plans today. God knows what we will decide in 5 years from now, as you know. Sometimes things change, but that's at least the current thinking that we have.
Thanks a lot, Frank. And maybe we've also seen from our international audience that people are also asking one question, which I want to summarize a bit and address to you as ESA ISS program manager. What is the perspective of the end of the lifetime of ISS? What is the present status really? We hear different figures, different dates from different partners.
What we are planning in ESA, and we have of course had the announcement of the US administration in December last year that they plan to extend the lifetime of the ISS till at least 2030. That is also what we are proposing to our ministers. It's what I presented today for the decision in the November Council, Ministerial Council in 2022. So we think this is a very good thing to extend the lifetime of the space station till 2030. We are certainly ready to do it, and from a technical point of view, there are no issues on the ESA side to do it. The question then is, what do we do after 2030? Is the commercial world ready to take over all the science experiments, all the requirements that we have to fly astronauts to low Earth orbit, to operate in low Earth orbit, to do all the research that we need to do, the technology demonstrators? If that is the case, then I'm sure that ESA will also look to cooperating with the commercial world in order to fulfill its objective, the ESA objectives, through more commercial endeavors. But if it's not the case and the space station is still healthy, maybe we extend the station further for another 2 years, 4 years. But again, this is future discussions that we will need to have with all the partners. But today, what I can say is that from all the international partners in the ISS Program Managers Forum, we are all looking forward to extend the space station till 2030 and continue to operate it till 2030.
Thanks a lot, Frank, for this update and for taking the time. Most interesting information from your side. Thank you. We will now move on to our next speaker, and the next keynote speaker will be Mr. Wang Xiaoyun. And the title of his presentation is Development and Prospect of Launch Vehicle Technology Serving the Space Station. Mr. Wang, I would like to invite you to the floor. Please give us your presentation.
这个是 PPT 是你来放是吧？好，尊敬的 Pascal Ehrenfried 的主席，尊敬的 Christine Fichtinger 主任，女士们、先生们、朋友们，下午好。刚才几位这个专家介绍了我们的这个空间站和这个空间站未来的深空探索的应用，非常精彩的报告。我在这里谈谈运载火箭的发展，题目是服务于空间站的运载火箭技术的发展与展望。飞向蓝天，飞向星空，探索浩瀚宇宙是人类共同的梦想。50年前，人类发射了第一个空间站礼炮1号，与联盟号飞船完成了在轨对接，宇航员在空间站内生活了23天。而今呢，中国空间站也将于年内完成建造并投入使用。时至今日，空间站的研究与应用已经取得了丰富的成果，给我们的生产、生活都带来了极大的便利和变革。运载火箭是人类进出空间的第一步，站在新的起点，面向新的使命。在新的时期运载火箭的发展也迎来了新的挑战与活力。我的报告分成4个部分，首先是介绍第一部分，载人运载火箭的发展的一个态势和历史。当前世界上已执行过载人飞行的火箭包括中国的长2 F 运载火箭、俄罗斯的联盟号系列运载火箭、美国的宇宙神 D 火箭、大力神2 LV-4 火箭、土星系列火箭、航天飞机、Falcon 9火箭、太空船2号和新谢泼德亚轨道火箭。1961年，属于联盟号系列的东方号运载火箭将尤里加加林送入太空，开启了人类载人飞行的序幕。目前呢，该系列运载火箭还在执行发射任务，是完成了载人飞行实验飞行次数最多的运载火箭。1969年，专门为登月任务而研制的土星5号运载火箭成功发射了阿波罗11号，实现了人类首次登陆月球。土星5号运载火箭总共发射了17次，包括11次载人飞行，其中6次载人登月飞行。近地轨道运载能力达到了117吨，是人类发射过的最大的运载火箭。1981年，航天飞机成功完成了首次飞行，它可以将7名航天员同时送入太空，是人类首个往返于地面和宇宙空间的部分重复使用航天运载器。从1972年至2011年，5架航天飞机先后执行了135次飞行任务，单架次最多执行了39次飞行任务。世界载人运载火箭从早期的探索应用到近年来是不断的蓬勃的发展。2020年，猎鹰9号火箭完成了首次载人飞行，并进行了垂直降落回收。单发火箭已经实现了11次重复使用，不断为国际空间站执行货运补给以及这个人员的轮换任务。2021年，太空船2号新斯伯德运载火箭也先后完成了亚轨道载人飞行，目前也将开创亚轨道的商业太空旅游的一个新的领域。世界主要航天大国如 中国、美国、俄国、俄罗斯都提出了新一代载人运载火箭的研制计划。太空发射系统这个今年呢还将实现首次飞行。SpaceX 公司的超重星舰首次采用了液氧甲烷推进剂，具备载人火星飞行能力和1小时内将100吨以后载荷全球点对点的运输能力，并且将是首个2级完全重复使用的运载火箭。纵观世界载人运载火箭的发展趋势，呈现出如下的一个特点。第一个特点呢，就是高可靠、高安全设计的日益的凸显。载人运载火箭由于涉及航天员的生命安全，因此呢，高可靠、高安全是国内外载人运载火箭的显著特点，也是载人运载火箭设计的首要准则。通过60余年载人航天飞行宝贵经验和教训的积累，载人运载火箭可靠性和安全性设计水平显著提升例如我们通过设置了这个故障检测系统和应急逃逸系统确保即使火箭飞行失败的小概率情况下，仍然能够通过逃逸系统的使用，让航天员迅速逃离危险区域，大大提高了载人飞行的安全性。二是载人飞行任务领域日益拓展。地球空间站实现了人类迈向太空的第一步，但是人类探索空间的脚步永无止境。各航天大国都发布了迈向月球、火星甚至更远深空的载人空间计划。刚才我们的欧洲的同事介绍了这个深空这个门户载人登月的这个计划。同时呢，利用太空资源，采用原位提取制造等技术，建立长期驻留的太空基地，为人类更好的探索宇宙创造条件。同时呢，探索广袤无垠的外太空，寻求新型可替代的资源，也是支撑人类文明可持续发展的一个重要的途径。三是技术应用创新日新月异。随着航天技术的进步，可重复使用运载火箭和载人飞船取得了重大突破。液氧甲烷发动机、智能化飞行、自逃逸等创新技术日趋成熟，商业的载人运输、太空旅游等创新领域得到了成功拓展。低成本、高效率的航班化进入空间的时代已经要到来了。未来的载人航天活动必将充满新的活力。下面向大家介绍一下中国的空间站的运载火箭系统。中国空间站命名天宫，包括核心舱天河、实验舱1问天、实验舱2梦天，每个舱的重量是在20吨级，总质量100吨，可支撑3名航天员长期在轨开展空间科学研究和运营的维护。未来也可以根据需要进行扩展，最大规模也可以达到180吨，长期驻扎6名航天员。而空间站的组装、航天员的乘坐、进驻、货物的运输都离不开运载火箭。运载火箭是空间站建设的和运行的基础。空间站建造阶段共要进行11次发射，目前呢已经完成了5次，今年呢还将有6次发射任务。后续空间站运营阶段预计呢每年要平均完成2次载人飞行和2次的货物补给的任务。同时呢，也可以根据任务需要开展拓展舱段的一个建造工作。长征2号F、长征5号B 以及长征7号是中国载人航天工程中的3型运载火箭，在中国空间站的建造、运营搭建了天地运输的走廊。其中呢，长征2号F 运载火箭用于执行神舟载人飞船的发射，它的近地轨道运载能力为8.2吨，具备将3名航天员送入空间站的能力。针对载人飞行设置了故障检测与逃逸系统，当火箭发生故障时，由该系统进行判断，发出逃逸指令，以及将飞船带离危险区域，并由飞船最终完成航天员的救生任务。长征2号F 运载火箭是目前中国可靠性最高的运载火箭，它的15次飞行实验全部实现了圆满成功。 长征5号 B 运载火箭用于执行天河等空间站舱段的发射任务，它的近地轨道运载能力达到了25吨。它是采用了5米直径的舰体、大推力的氢氧发动机等相关的技术。特别是长征5号 B 运载火箭可以通过助推器加新一级，就可直接实现这个舱段的发射入轨，是目前中国最大的运载火箭。长征7号运载火箭用于执行天舟货运飞船发射任务，它的近地轨道运载能力达到14吨，也采用了超静电捆绑等技术，并且呢，火箭全部采用了液氧煤油的推进剂。下面向大家介绍一下中国下一代载人运载火箭发展的构想。世界航天技术现在是突飞猛进的发展，人类进入空间的需求也日益迫切。各个航天国家都提出了下一代运载火箭的升级换代计划。应该说，从现在来看都聚焦于下面几个方面的特点：一个是要更高的质量，更高的这个品质，更高的飞行成功率，通过随着技术的改进与成熟，飞行的成功率要提高到99%以上。要高效率，要更快的发射频率，全球年度发射次数有望提升至每年到200到300次。另外一个趋势特点就是要低成本，要通过更低的发射费用，要单位载荷的发射成本力争降到当前的50%。未来5年，中国将完成新一代载人运载火箭的研制。新一代载人运载火箭将采用模块化、通用化设计，同时具备载人和载货的运输的能力。近地轨道空间站的任务呢，是采用了2级串联构型，它的一子级具备重复使用能力，低轨道的运载能力呢，在重复使用的情况下达到14吨如果一子级不重复使用，它的运载能力可以达到20吨。月球1源的探测任务采用3级加助推器的构型，它的地月转移轨道的运载能力呢，达到了27吨。火箭一子级采用新型垂直起降可回收的方案，载入过程在发动机减速的基础上，还将利用气动舵进行控制和减速。目前考虑着陆阶段呢，采用网系回收装置，将更多的返回用的机构从舰上转移至地面，减少舰上的负担。它同时呢，利用网系绳索呢，对火箭进行阻尼减速，以实现一子级的软着陆。另外呢，也在同步研究低成本的液氧甲烷运载火箭，采用新型液氧甲烷推进剂，一子级主要采用垂直起降回收，二子级采用带翼回收，实现全舰所有模块的重复使用。LEO 运载能力呢，能达到20吨，具备空间站物资的上下行的运输能力。低成本液氧甲烷运载火箭在空间站物资运输形式上，全球到达的范围、单次运输的规模、载荷的种类、多次运输的成本、重复使用次数上都具备良好的适应性，可以大幅度的降低空间运输成本，提升进出空间的效率。最后呢，我们在升力式天体往返运输系统领域呢，也在开展研究，也在开展研究。升力式天地往返运输系统是一种以火箭发动机为主动力，地面自主垂直起飞，水平着陆2级升力体并联构型重复使用天地往返运输系统。一子级呢，这个是通过无动力的可控的返回水平着陆。二子级自带的火箭动力爬升入轨，完成任务后呢，也是按需返回地面，采用着水平着陆。具备快速进入空间、升力式高速返回、航空低空滑翔等技术特点，采用升力式构型、低温无毒无染液体火箭动力实现火箭动力垂直进入到大公交可回返回 无动力水平着陆的飞行剖面，最终达到天地往返航班化运输的目标。下面介绍一下未来运载火箭技术发展的一些思考，主要包括4个方面。首先是对动力方面的思考，新型动力呢将实现进出空间方式的一个变革。液氧甲烷推进剂具有不易结交、易维护、低成本等特点，在重复使用运载火箭中的应用具有显著的优势。同时呢，液碳甲烷具有利于空间运输和原位制取的优势，是后续人类大规模深空探测的首选。中国和美国的液氧甲烷火箭预计今年都将完成首次飞行。液氧甲烷发动机呢，也将成为运载火箭领域的重要的一个新生力量。同时，一些新型的发动机，比如说 RBCC、TBCC、PATR、SABR 等组合循环的发动机具有高比冲的显著特点。组合动力重复使用运载器具备灵活起降、航班化运输的能力，与采用火箭发动机的传统航天运载器相比，具有更丰富的飞行任务模式、更快的响应时间、更强的机动能力和更高的经济性。近年来，我们也针对组合动力运载器开展了关键技术的一些飞行演示验证，以后也将带来进入空间方式的变革，为单机入轨的航班化天地运输奠定一定的基础。根据深空探测任务的发展需求基于化学推进的系统的飞行器实施难度太大，急需开展先进推进技术研究，如核推进技术。核热推进的比重达到900秒，具有高比重、大推力、长工作寿命的特点。基于核动力的空间运输平台将大大提升和改善轨道转移运载器的性能和能力，显著降低任务规模和地面发射次数，实现大规模进入空间和执行深空探测的任务目标，特别是在未来深空探测中具有重要的应用前景。其次呢，我的新结构呢也将实现运载火箭的一个效率的提升。火箭结构也是向着集成、高效、协同的方向发展。火箭材料以高性能、低成本为目标，持续更新的航天的金属和非金属的材料。制造工艺方面呢，3D 打印为火箭复杂结构一体化设计制造提供了重要的支撑，也被大量的应用的发动机等复杂结构关键产品的制造过程中间。同时呢，随着低温复合材料、3D 打印、PM 泡沫供底等新材料、新工艺的演进突飞猛进，运载火箭结构轻质化水平已经升级换代，进出空间的效率特别是运载火箭的效率呢也将大幅提升。未来运载火箭的飞行任务剖面更加复杂，建立结构呢也将由单一的结构向多功能结构，由成立结构向运动结构发展，通过多学科优化来提升轻质化水平。通过结构设计也实现航天器的多功能化，要满足更大、更小、更多有效载荷的连接释放，实现重复使用所需水平或垂直返回以及气动外形的变化，采用气驱动或电驱动等非火控能源形式呢，来保证可检、可测、可靠。同时呢，既提供运载器动作执行所需的正功，也能作为着陆等缓冲机能的副功。第三呢，智慧控制将实现飞行可靠性的跨越。随着以微电子、微机电、微激光电为代表的电子技术、信息技术和人工智能技术的发展，以及更智能化的技术的应用，运载火箭的故障诊断手段和能力日新月异。通过健康管理以及自主飞行的重构，针对飞行故障准确检测、快速响应，实现发动机等点云产品故障下的正常入轨，由自动飞行向智慧飞行的跨越。短期之内呢，运载火箭智能发展，我们认为主要以控制系统为主线，逐步应用系统容易、专家系统、统计模型、机器学习等新技术硬件，实现本体与环境的在线辨识、运载能力在线评估与规划，以及控制的在线重构等，具备个体强适应、任务快响应的特点。未来运载火箭智能技术发展呢，将以物联网、大数据和人工智能为基础，通过全生命周期数据的充分利用和挖掘，实现建模、仿真、制造、实验、发射任务自主迭代和升级，具备未来的航班化、智能化和模块化的特征。第四呢，重复使用将实现天地往返运输的航班化运营。重复使用技术不仅从产品自身达到降低费用的经济目的，而且具有广阔的商业市场， 将极大推动空间产业革命性变化。随着人类活动范围的逐步拓展，空间服务、空间加工、空间旅游等产业逐渐兴起，民商用的地球成像、快速货物运输、高速的旅客运输等已出现端倪。人类太空活动的规模在60余年的时间增长了上千倍，太空经济日益呈现出基础性、强关联性、高牵引性、高增长性特点，成为世界经济发展和人类生活的重要组成部分。因此呢，像飞机一样实现航班化运营是航天运输系统发展的必然趋势。利用可重复式运载火箭加升力式运载器的技术，构建天地往返运输加1小时全球抵达运输加空间转移运输的系统满足未来人类大规模、高效率进入太空的需要。在报告的最后呢，我也想说呢，新材料、新能源、人工智能等现代科学技术正在突飞猛进，人类对探索宇宙的美好渴望日益旺盛，航天运输的革命时代已经在到来。中国航天人也将秉承开放融合的发展理念，与全世界航天工业界的朋友和航天爱好者团结协作，勇于技术创新，和平利用太空，共同推进运载火箭技术的升级换代，实现人类自由进出空间的伟大梦想。也谢谢大家。
Thank you very much, Mr. Wang, for this outstanding perspective of the development of human-rated launch vehicles in the future. Will we have some questions from the audience in Beijing? Yeah, I think we have a question.
王院长您好，您刚才向我们介绍了支撑空间站建设的中国的这个运载火箭的发展，您也提到了我们未来新一代的运载火箭具有地月转移的运输能力，那想请问您一下，我们这个运载火箭未来的发展规划中是否有考虑到载人火星探测？谢谢。
应该说，载人火箭探测目前也处于在探索和研究阶段，因为毕竟载人火箭探测对运载火箭能力有一个跟相比载人登月有更大的要求，目前还处在研究阶段。这也是我们目前在国际 IAA 的支持下开展的课题研究这个目前还没有列入正式的规划。
谢谢您。
Thanks, Mr. Wang. Our international community is very much interested to ask you when we will see the first Chinese launcher reusable first stage in operation.
运载火箭的重复使用呢，目前也我们一直在开展这方面的探索和研究。就跟刚才我们在报告里讲的，我们的运载火箭的重复使用呢，也是沿着两条路径，一个呢是这个垂直起飞垂直的着陆一个呢是垂直起飞水平的着陆。这两个路径呢，中国运载火箭研究院目前都在开展研究。我想预计在未来的几年时间内吧，我们可能会组织开展演示飞行和提供一个和进一步的这个工程化应用。
Thank you very much for this interesting insight once again. And I think it is now time to move on to our next speaker. Once again, thank you very much, Mr. Wang.
好，谢谢大家。
Our next speaker now is Mr. Sergey Grikalyov. He is the Executive Director of Human Spaceflight Programs at the State Space Corporation Roscosmos. And of course, we all know him as a world-famous Russian record cosmonaut. After graduating from the Leningrad Mechanical Institute and earning a degree in mechanical engineering in 1981, Sergey Grikalyov became an engineer and 4 years later became a civilian trainee astronaut. He was selected as a cosmonaut in 1985. In a year, completed his basic training and was assigned to the Buran shuttle program. Sergey has made 6 space flights, from his first flight in 1988 to his 6th flight in 2005. He has made 8 spacewalks, and for 10 consecutive years, he was the holder of the world record for the duration of a total stay in space of 803 days, 9 hours and 42 minutes. He was in space when the Soviet Union was dissolved on December 1991. His return was delayed, and he stayed on board the Mir station for 311 consecutive days, twice as long as the mission had originally called for. Sergei Krikalev was also the first Russian cosmonaut to fly an American shuttle in 1994. And in 1998, he participated in the first mission to the ISS to assemble it. And in October 2000, Sergei Krikalev began permanent manned presence to the ISS as a member of the first long-term international expedition crew to the ISS. And now I'm pleased to hand over to Moscow to Sergei Krikalev for his keynote titled Russia's Perspective on Human Spaceflight in Low Earth Orbit. Sergei, please.
Thank you, Christian. Good day or good evening for everyone, and thank you for presentation. My message would be relatively short. Maybe we can leave a little more time for answers and questions. But basically, I was asked to talk about future human space flights in Russia on low Earth orbit, and for now, our plans, as was already told, we are going to extend space station life until 2030. We also, the same way as in Europe, we need to work with our government to make it go through official decision-making process. But programmatically, we are ready to extend lifetime of the station, the Russian segment of the station, until year 2030. In the future, of course, we are going to stay on low Earth orbit, and right now we start to engineering process to estimate what our flights are going to be in the future. We have several options, and you probably heard it about one of the options to create station on high inclination orbit to be able to observe all Earth surface. We're still looking at the option to extend lifetime of ISS and Russian segment on ISS and dock new modules to ISS, and then maybe detach it when it's needed, and continue fly as a new station, separate station on low Earth orbit if International Space Station is going to stop flying. Of course, we are sure that no matter where we fly and how we fly beyond low Earth orbit, we will stay on low Earth orbit first as a base of future exploration, and secondly, this is our basically base on orbit, base in space, and no matter where we fly, we go probably through low Earth orbit anyway. If we are going to fly to Moon or to Mars, first stop would be on low Earth orbit. So for this purpose, we are looking at different design of new modules. We start engineering process to estimate different scenario and different efficiency of this flight. And of course, for low Earth orbit, we will need transportation system. As it was already told that we still use Soyuz rocket, which have several stages of modernization, and we use very reliable rocket and spacecraft up to now. And of course, we will need to have some kind of transportation system for low Earth orbit. And for now, we are using different scales of rockets. one rocket, Proton, or in future Angara, are going to send between 20 and 27 tons on low Earth orbit. Basically, are going to be cargo vehicle that are going to send modules on orbit. And human-rated rocket, for now, we are using Soyuz that can launch 7.5 or 8 tons cargo on low Earth orbit. And also, we are working on next generation vehicle that is going to launch probably 12 ton initially, and then up to 14 tons on low Earth orbit that potentially can be human-rated in the future. So that's our nearest plans. If you have any questions, I'm ready to answer.
Many thanks, Sergey, for this also very concise and exciting perspectives of the development in Russia. I would like to open up the floor for questions from the audience in Beijing, please.
非常荣幸能够向您提问。我的问题是，就是想了解，我们从网上也了解到，俄罗斯正在开展下一代可重复使用运载火箭的一个研制，也就是阿穆尔火箭。所以说，想了解一下，就是后续咱们是否会考虑使用重复使用运载火箭来完成载人和货运的一些任务，以及我们现在主力火箭联盟号火箭。 到了那个时候，是否有一些退役等一些计划？好，谢谢。
I may not understand end of your question, but if you're asking about reusability of Soyuz launch vehicle, that's probably answer would be no. This is a relatively old rocket. It's very reliable, but make a change in it is not going to be very efficient. We are looking on several scenarios for reusability, and one of them would be basically the same idea, same technical restrictions, but we are going to use reusable first stage. But unfortunately, it's not free of charge, all this reusability, because if you use reusable first stage, it actually reduces your capability to send cargo on orbit. And at this point, it's not economically efficient, but in future with developing technology and developing control systems, it can be economically efficient. But at this point, we look at two different options. One would be winged return back and landing, vertical takeoff and landing using wings on airfield. And second option is vertical landing using rocket engines. So that's our plan for nearest future. And actually, talking about current days, 2 days ago, next Soyuz with cargo vehicle Progress was launched from Baikonur, and actually today, about 6 hours ago, Progress vehicle was docked with the station, so we continue flying and supporting International Space Station.
Thanks, Sergey, and congratulations to this outstanding success again. Do we have more questions from China? Yes, I see more. We have some more minutes for questions.
Christine, only one very simple question. What is the inclination angle of the Russian's new space station?
Sergey, you are muted.
We look at two different options. One proposal from engineers is to fly on high inclination, basically polar orbit, and it has some advantages and disadvantages. And second scenario, probably not the only scenario, but we, as a one extreme, looking at polar orbit, and second extreme is staying on same inclination as International Space Station flights, 51, 52 degrees inclination. We also probably through engineering process will look at intermediate inclination such as 65 or 72 degrees, but we are now in engineering phase of estimating advantages and disadvantages of every inclination. The final decision is not made yet.
Thank you. Any more questions from Beijing? That is not the case. I see some questions from the international audience. They are interested in finding out the status of the next generation human space transportation spacecraft in Russia.
We actually keep developing our new spacecraft, and the launch vehicle for that is going to be Angara, is a heavy launcher, and future next generation spacecraft is going to be actually moon rated or moon orbit rated. The next spacecraft is built to be able to fly beyond low Earth orbit, to be able to fly to moon orbit and return crew back safely with high-speed re-entry to Earth. So we keep processing of this vehicle, and the first flight is first test flight is scheduled at the end of next year, and probably most of tests would be done in year 2024.
Thank you very much, Sergey. I think there was one more question from Beijing. There was one more arm going up.
尊敬的谢盖先生，你好，我想请教一个问题。众所周知，那个中国、美国和欧空局都在研制液氧甲烷火箭。请问俄罗斯方面对液氧甲烷火箭是什么样的观点，或者有没有相关的研制计划？谢谢。
Yes. We have planned to develop a rocket based on liquid oxygen and methane. It's as was already told that it has some advantages, especially for reusable rockets. And also we had before a high power and high efficiency engine with liquid oxygen, liquid hydrogen. And we are going to have another stage for upper stage for Angara rocket that will increase launch capability of the rocket to increase mass of the cargo that can be delivered to a low Earth orbit. So we are developing liquid oxygen, liquid hydrogen engine for upper stage, and we are working on liquid oxygen and methane first stage and second stage.
Thanks, Sergey. I have one more question from the international audience, and that is about Russia's plans for human exploration beyond low Earth orbit to moon orbit and to surface.
As I already told, that a new generation of spacecraft that we are building now is going to be able to fly beyond low Earth orbit, and it's actually designed to fly to moon orbit and return crew back. This is the first stage of future exploration, and the second stage of exploration would be developing of lander and to have future landing capability and capability to build base on the moon. So for our current plan, we are going to do this in time scale about year 2030, 2035.
Okay, thank you very much, Sergey. There would be time for one last question from Beijing, if there is one. No more questions. Thank you very much, Sergey, for taking the time and being with us. And I hope you will be able to join us at the closing again for a group photo. We have just one more presentation. Let's see.
Thank you.
Okay, thank you very much. And now we move on to our last speaker, actually, complete our global journey discussing the topic of human spaceflight in low Earth orbit. It is my great pleasure to present our last keynote speaker for today, Mr. Gilles Leclear, Director General of Space Exploration from the Canadian Space Agency. Gilles Leclear joined the Canadian Space Agency, CSA, as it was being created in 1989. He worked as a project engineer, manager, and then director in a variety of technology developments, satellite communications, and international space programs. Between 1997 and 2000, Mr. Leclerc was posted to the Canadian Embassy in Paris as counselor for science, technology, and space affairs, representing Canada at the European Space Agency. He became Director General, Space Technologies in 2004. And since 2010, Mr. Leclerc has led the CSA's space exploration program, which encompasses Canada's participation in the International Space Station, space robotics, human space flight, life sciences, astronomy, and planetary missions. He and his team are currently working on Canada's lunar program. Mr. Leclerc is a member of the Canadian Aeronautics and Space Institute, the American Institute of Aeronautics and Astronautics, and the Order des Ingénieurs de Quebec. He is currently also the chair of the International Space Exploration Coordination Group, the ISEC-G. Unfortunately, due to the time difference, we will not have Mr. Leclerc live with us, but through a pre-recorded video presentation. And this presentation is titled A Canadian Perspective on Human Spaceflight. Please enjoy the presentation video. If you could please run the video now. Thank you. just hear that the IAF press trying to join us again and waiting to let her enter link. So if you could do that, so that we have her available.
I'm here. Is it so that the moderator is probably frozen?
Hello, can you hear me again?
Yes.
Okay, thanks, guys. I'm sorry I fell out. My internet connection was a bit unstable. I'm back now, and I'm very happy to see that, Pascal, you are also back, and Sergey, thanks for joining again. All this brings us actually to the end of today's symposium and to our closing ceremony. And I'm not going to attempt to summarize what has been presented to us today by such high-level specialists from all over the world. I would just like to share my impression and my firm belief that human spaceflight in low Earth orbit and beyond is going to bring most valuable scientific, technological, societal, and also political benefits to humankind. And I think we can all look forward to seeing many more exciting missions in the coming years and months. I would like to get back or remind one saying which Mr. Wang Xiaoyun has mentioned at his opening remarks, and that was, as a lake or a sea is not going to be filled by one river only, meaning cooperation, putting all the efforts worldwide together to reach a common goal is of key importance. And I think this was also reflected very well in all the presentations today. And I also look forward to be able from the IAF side to contribute to setting up new partnerships to foster cooperation. Let me now thank and express my sincere thanks to all our outstanding keynote speakers. They really deserve another round of applause. If you could join me for another round of applause. And my thanks go also to our partners and co-organizers, the Chinese Society of Astronautics and the China Academy of Launch Vehicle Technology for the initiative and for the outstanding organization. A big thanks also goes to our on-site audience in Beijing. It's quite late already on your side. And to all the people who have followed the symposium from remote. I've been informed that it was more than 1,600 people that were listening in from remote. So that's a tremendous achievement. I would like to inform you that we have recorded the entire program and it will be made available for rewatch through the IAF website, and I'm sure also through the Chinese Society of Astronautics website. Let me close by asking now all speakers in Beijing to get together, and all remote speakers. I think we have only Sergey and Pascal. Frank needed to leave for another meeting urgently, to stay in front of their cameras for a group picture.
这样各位领导，我们刚才就做报告的，还有这些领导们，我们跟他们做一个做一个集体的合照，就是怎么实现？他们在上面飘窗，然后我们在前面吧。对。 这是摄像机摄像头旁，这样的摄像头旁这个怎么实现这个？
Maybe you can change the screen to show us all. Yeah.
往这边连着嘛。这边再来，会部长，您到这边正好这边少一个人，这边是不是有4个？
If you could clear the view a bit, the two ladies in front, so that we can also take a picture from our screens.
Christian, thank you.
Thank you all.
Thank
thanks,
you.
Pascal. Thanks, Sergey, for staying on. And thanks, Yao and Mr. Wang,
Thank
all our
you.
colleagues in
Thank you.
China.
Bye bye.
All the best to
Yeah.
you. Bye bye.
Bye bye.
Thank you very
Bye
much.
bye. Bye bye. Okay.
现场我们知道主视觉再照一张，我们现场再照一张，来这个照一张，来，请大家再上，好，照一张。后边再带来。往那边是2个，往这边是2个。好，对，好，各位领导来，到这里来准备，来，1、2、3，左飞几张，来准备，1、2。